Our topic today is lighting. In this lecture episode, I propose to discuss different properties of light and study the different lighting situations. Light is a medium through which a camera person lights up a situation. Therefore, it is utmost essential for every aspiring camera person to study different properties of light and the lighting situations. Optics is a branch of physics that describes the properties of light and how light interacts with matters. Light is a form of energy visible to human eye. Light is one of many forms of electromagnetic radiation that we encountered in nature. Light propagates in a straight line and always moves in a constant speed of about 3 lakhs km per second or 1,86,000 miles per second when it travels in a vacuum. At times, light behaves like a particle and like a wave at other times. Photon is a particle of light energy. Moving electrical charge generates photon. Photons are different from particles of other matters. Photons neither have electrical charge nor any mass. Scientists use the concept of photon to describe the effect of radiation when light behaves like a particle. As light passes around the corner, it diffracts a bit or bends slightly. This is an example where one can experience the wave-like behavior of light. The waves associated with light are called electromagnetic waves. Electromagnetic waves are formed when an electric field couples with electromagnetic field. Electromagnetic wave travels in waves and spans a broad spectrum from very long radio waves to very short gamma rays. The human eye can only detect a small portion of this spectrum called visible spectrum. The entire range of electromagnetic waves are arranged together according to the frequencies or wavelengths in electromagnetic spectrum. Frequency corresponds to the number of wavelengths that pass by a certain point in space in a given amount of time. This is usually measured in cycles per second or hertz. The wavelength of a wave is the distance between two consecutive wave peaks. Wavelengths of a visible light can be measured in nanometers, which are 1/1000th of a meter. X-rays have wavelengths ranging from several thousands of nanometer to several nanometer. Radio waves have wavelengths ranging from several meters to several thousands meters. Waves with frequencies a little higher and wavelengths little shorter than a human eye can perceive are called ultraviolet, and the wavelengths with little lower frequencies and longer wavelengths than the range of human vision are called infrared. We generally acquire light from 3 different sources, namely the natural, bioluminescence, and artificial light sources. Natural light sources include the sun, stars, and lightning. Bioluminescent sources is produced and emitted by living organisms. Artificial light sources are the light produced artificially. Further, the artificial light sources differ in how they provide the energy to the charged particle, such as electrons whose motion creates the light. Accordingly, artificial lights can be further classified as incandescent, luminescent, and fluorescent lights. If the energy comes from the heat, then the source is called incandescent. If the energy comes from the chemical or electric energy, the source is called luminescent. A fluorescent light is a type of luminescent source that makes use of the chemical compound called phosphorus. Fluorescent tube lights are filled with mercury vapor and coated inside with phosphorus. As electricity passes through the tube, it excites the mercury atom and makes them emit blue, green, violet, and ultraviolet light. The electrons in the phosphor atoms absorb the ultraviolet radiation, then release some energy to heat before emitting the visible light with a lower frequency. Fluorescent lighting may appear to be constant, but it actually changes in accordance with the frequency of the power source. The human eye is not capable of detecting such fast variations. Light behavior can be divided into two categories. One is the propagation of light through space or through transparent materials, and the other is the interaction of light with matter. The propagation of light through space or through transparent material has much in common with the propagation of other kind of waves that include sound waves and water waves. Light incident on any matter interact differently depending on the material, its color and texture. If the matter is opaque, it absorbs certain light and reflects certain light. Absorption and reflection also depends on the color and the texture of the material. Transparent matters also absorb certain light and reflect certain light, but it allows maximum amount of light to pass through. Translucent matter absorb more light than do transparent matters. Reflection occurs when the light hits the boundary between two materials and the light undergoes a change of path and passes to the first material. The laws of refraction states that when a ray of light reflects off a surface, its angle of incidence is equal to its angle of reflection. Light that reflects from a flat boundary, such as a boundary between air and a smooth lake, will form a mirror image. Light reflected from a curved surface may be focused into a point, a line, or into an area depending on the curvature of the surface. Refraction is a bending of light path. Refraction takes place when the light passes from one transparent material to another transparent material. Refraction depends on the media through which the light rays are traveling and caused due to the difference between the speed of light traveling through different transparent materials. The law of refraction, credited to Willebrord-Snell, states that the ratio of the sine of the angle of incidence and refraction is equivalent to the ratio of the phase velocities in two media, or equivalent to the reciprocal of the ratio of the indices of refraction, that is, sin theta 1 by sin theta 2 is equal to v1 by v2 is equal to lambda 1 by lambda 2 is equal to n2 by n1, where each theta is the angle measured from the normal of the boundary, v as the velocity of light in respective medium, lambda as the wavelength of light in respective medium, and n as the refractive index of respective medium. Dispersion takes place when white light passes through a prism. It refracts the light of its spectrum at a different angles and thus separates colors. Light of shorter wavelengths deviates more from the original path than the colors with longer wavelengths. Red light bends the least and the violet light bends the most. In order to harness the power, dynamism, and distinctive nature of light, it is absolutely necessary for a camera person to understand the basic characteristics of light. The three basic characteristics of light are intensity, coherence, and color temperature. Intensity of light may also be referred as the quantity of light. Intensity is one of the main characteristics of light that you need to pay attention in any environment where you intend to take the photograph. The intensity of light depends on the source's brightness and the distance from the source. Luminance is a measure of intensity of illumination on a surface. Luminance is measured in foot candles or lux. A foot candle is defined as the amount of light received by a 1 square foot surface area which is 1 feet away from a candle of certain type. Lumen is abbreviated as LM. Lumen is the measure of the total amount of visible light present. Output of artificial lights can be measured in lumens. Lux abbreviated as LX. Like foot candle, lux is also a unit that measures the intensity of illumination on a surface. 1 lux is equal to 1 lumen per square meter. Thus, lux is referred as the meter candle. 1 lux is equal to 0.0929 foot candles. Intensity of light radiating from a point source is inversely proportional to the square of its distance from the source. We find the application of inverse square law in photography to estimate the fall-off or the difference in illumination of light as the subject moves close or further away from the light source. For quick approximations, it is enough to remember that doubling the distance reduces the illumination to 1/4. When the illuminant is not a point source, the inverse square rule is often still an useful approximation. When the size of the light source is less than 1/5 of the distance to the subject, the calculation error is less than 1%. Coherence is often called quality of light. Coherence refers the hardness or softness quality of light. Hard light is produced when light is emitted directly from a small point source and produces parallel rays. Light from a clear unfrosted bulb, focused spotlight, a candle is some of the examples of hard light source. Though sun is a big source, but as it is far away distance from the earth, therefore the beam of sunlight reaching on the earth's surface is relatively parallel rays, and consequently it is also treated as hard light source. Hard light casts sharp shadows and help bringing out texture of any object, and on the other hand, soft light tends to hide surface irregularities and details. Soft light is produced when light is emitted from a broad source and results in a diffuse scattered rays. Light from cloudy sky, frosted bulb, light passing through a diffusion screen or bounces from a broad area represents soft light sources. Look at these two photographs. In both, the object as well as the two variables of light, that is the intensity and the color temperature, are exactly the same. The only difference is the coherence. The photograph in the left is illuminated with soft light and the one on the right is illuminated with hard light. When a solid object is placed on the path of a light rays, it blocks the light path and creates light, dark, and casts shadows. If the light travels from a point source, it casts only a simple shadow, like umbra. The umbra is the darkest part of the shadow where the light source is completely blocked by an obstructing body. A solid body with angular surface shows sudden contrast of light and dark. On the other hand, a spherical surface demonstrates as an even flow of tones from light to dark. This creation of light and dark tones vary and are less predictable when the light is composed of several light sources. For a broad or extended light sources, the shadow is more blurred and the shadow extends from umbra, penumbra to antumbra. The penumbra is a region in which only a portion of light source is blocked by the solid object. And the antumbra is a region where two penumbras overlap. The shadow appears to merge. Color temperature refers to the hue of light. Color temperature is a borrowed term from physics. In physics, a black body is a theoretical perfect absorber which absorbs radiation of all wavelengths falling on it. At normal temperature, a black body reflects no light and thus appears black. When heated, the black body radiates light. The hue of that radiated light depends on the temperature of the black body. The color temperature of a light source is a temperature of an ideal black body radiator that radiates light of comparable hue to that of the light source. The temperature of black body is measured in degree Kelvin. You probably know this effect from everyday life. If you heat an iron bar, it will eventually be red hot and start to glow dark red light. If you further heat the iron bar, it will turn yellow like the filament of a light bulb and eventually blue-white. The hotter the body, the color moves from red parts of the spectrum towards the blue parts of the spectrum. But we know that red is warmer color than blue, so a warm body radiates cold color and a comparatively cold body radiates warm color. The objective of study the characteristics of different lighting situations in details is to develop a better understanding of light so that when working with them we can utilize them the most. To learn lighting, first we explore different situations. Then we learn how to manipulate lights to recreate the similar situations. Thereafter, once we have experience in recreating situation, we apply that knowledge to develop a lighting situation of our imagination. Generally, we encounter three kinds of lighting situation: outdoor daylight, where sun is the source; indoor lighting situation, where artificial tungsten or fluorescent lamp fixtures are used, or some combination of these two. Daylight is a gift of God. Daylight comes to us free from the day one. Since our birth, we spend considerable amount of time, that is from dawn to dusk, in the daylight. Thus we are habituated to experience the world around us in daylight, and that makes the different daylight lighting situations very natural to us. Direction of sunlight is predictable. At the dawn, the sun rises in the east and sets in the west at dusk. But unfortunately, the quality of sunlight is unpredictable. Quality of daylight depends on season, weather, and time. The nature of sunlight changes rhythmically throughout the day. The color of daylight shifts from cool pre-dawn twilight through golden glow just after sunrise to the natural white light at noon. The daylight illumination also varies from 1 lakh lux for direct sunlight at noon to less than 5 lux for the thickest storm clouds with the sun at the horizon. How many of you have experienced the daybreak? If you haven't, I suggest have a first-hand experience. It's just magnificent. At the first, the sky in the east gets a dash of light and slowly it brightens up. This time of the day is marked as dawn or twilight. At night, you cannot distinguish the horizon from dark sky, and during twilight you can. That is the difference between night and twilight. At twilight, the sun rays bounces off the uppermost atmosphere and reach the earth's surface with cool bluish light, and the intensity of light is very poor and diffused. As the sun appears on the horizon, sunlight travels through a greater depth of atmosphere and appears warmer, having a color temperature around 2000 Kelvin. The water particles present in the atmosphere absorbs the UV light, and the dust particles present on the lower part of the horizon acts like a filter which absorbs the blue-green part of the spectrum. The atmospheric haze also reduces the intensity of the direct light and can be as low as 400 lux. Since most of the illumination comes from indirect light bounces from the sky, it also reduces the lighting ratio. In addition, the sun's small angle with the horizon produces longer shadows. The beautiful color and relatively low contrast sunlight during the golden hours makes this a great time to photograph. Golden hour is the favorite light for many camera persons. About an hour after the sunrise, as the sun continues to rise up, its rays pass through a thinner layer of atmosphere. The color of sunlight shifts from warm to neutral. The average color temperature of daylight is 5600 Kelvin. The intensity of sun peaks at noon. It varies between 32,000 to 1 lakh lux. With the increase of intensity, the shadow density and the contrast also increases. Then the cycle reverses itself. In the afternoon, as the sun continues across the sky to the western horizon and beyond. Apparently, there is no inherent natural causes of a major optical difference between dawn and dusk. Average intensity of light at sunset remains almost same as sunrise, which is around 400 lux. It also has longer shadows because of the sun's small angle with the horizon. However, as there is more particles in the air at the time of sunset than at sunrise, which is caused by daytime activities of human beings, animals, plant life, and general warming of ground and water bodies, it turns the hue of the sunset light much warmer. The average color temperature of sunset may be around 1800 Kelvin. Daylight enters inside the building or factory through openings such as doors, windows, and skylights. Such openings are nowadays introduced to save energy and also for aesthetics. Interior lighting condition varies constantly at different times of the day depending on its position. The ratio between an external light level and the amount of light received into an interior space is referred as daylight factor. Constant efforts are being made to conserve energy by making more openings in the building and reducing the use of artificial light during the daytime. Exterior nights are illuminated by artificial light, and all sources of artificial light essentially consume energy, and we need to pay for it. Light of exterior night scenes are contrast in nature. When lighted up with incandescent or sodium vapor lamp, it dominates the warm color tones, and when lit up with fluorescent lamp produces cool color tones. Lighting of night interior depends on the type of light arranged. Look of candlelight situation is marked different than an area illuminated by incandescent bulb or fluorescent tube light. Tungsten light has a yellow-orange color and daylight often has a blue color. A subject photographed in this lighting can have yellow-orange light on one part of them and blue lighting on the other part of them. With this, we come to the end of the lecture episode. So far in this episode, I discussed about the different properties of light, the position of visible light in the electromagnetic spectrum, how light interact with different matters, different types of light sources, and their basic characteristics so that we can study thoroughly the different lighting situations.